Hey Algebra 2 students, here is the lesson video for lessons 4, 5, and 4, 6. We're going to be talking about Determinant and Cramer rule. We're going to do Cramer's rule, which allows us to solve systems of equations. We have to first be able to know what a determinant is. Determinants are actually pretty easy. There's this big fancy formula up here, but all that formula says is that we're going to multiply top down. We're going to multiply those two things in the corners, multiply bottom up, and we're going to take the difference of them. So 30 minus negative 24 is the same thing as 30 plus 24. So my determinant of this 2 by 2 matrix is just 54. And right now that number doesn't really mean much to us, but it will when we start using Cramer's rule. So let me show you another one here. I do top down, I do 11 times 3 is 33, minus bottom up, 9 times negative 5 is negative 45. Again, that adds, so we now have 78. Two examples there. All right, now that we know how to do determinants, we're going to use these to solve systems of equations. The really cool thing about matrices is they allow us to solve systems of equations without using substitution and elimination, which can be really time-consuming and take up a lot of paper. So the first thing that we have to note here is in order to use our Cramer's rule, we have to be in standard form. We have to have ax plus by equals c, where these numbers are not only whole numbers, let's write that down, so whole numbers, because it's in standard form, but we also have to have a positive coefficient for x. So this a has to be positive. Once we hit this, again, we're going to use these really cool handy-dandy little formulas. We've got an x formula and a y formula, and we're just going to do this in two parts. So here's my first part. So let's first determine what our x is from these two equations. This here. As I'm starting to learn matrices and how to use these formulas, I like to write down what each of my variables is going to be. So I notice I have an a, b, c, d, e, f. But it's hard to put them into this form if I don't have them just written down off to the side. So my a is going to be my coefficient in front of x in my first term. That's a 1. My b is my coefficient in front of y. Then I have my c is my coefficient in front of x in my second. So it'd be 3, negative 1. And then my e and my f are my two solutions, 17, 29. Once I have these written down, it's really easy to plug them into my determinant matrix. X equals, I set these two pieces up. I do want to note, when we have these bracket bars, I'm sorry, not these brackets, when we have these straight bars on either side, because we're now working with matrices, these are no longer symbols for absolute value. These are now telling us we need to find the determinant. So do not get these confused with absolute value. It will affect your answer. All right, let's set it up. So my formula says I need e and f right here. So I'm going to take e and f. I do 17, 29. And I need b and d. B and d, negative 4, negative 1. And then I'm going to set up a, b, c, d. This is the easy one because you can just take the coefficients from each of these and just ignore the letter values that are with them. So I'm going to take 1, negative 4, 3, 1. Sweet. Once we have that set up, I'm going to take these down here. And now this is where those determinants from up above come in. We're going to find the determinant of each of these 2 by 2s, divide because that's division bar means, and we're going to put our x equals. So let's do that. On top, we get 17 times negative 1, that's negative 17, minus negative 4 times 29, 116, over 1 times negative 1, minus 3 times negative 4. Simplify both of those, you get 99. On the bottom, you get 11. And your final answer here is 9. x equals 9. Now you may say, Miss Bray, that's still a lot of work, except it's a lot of work, but you didn't have to use any letters like you would have to do in elimination and substitution. But we're not quite done. We still haven't found y. So that's where we're going to jump over and use our second formula piece. Same concept. We set up our two determinants, top and bottom here, and then we just plug things in where they go. A and C, 1 and 3. E and F, just like we did in the other one, 29. As you get faster with these, you'll notice a significant number of patterns. One of the patterns that you're going to see is that your y and your x share the same determinant on the bottom. It's still ACD, ACBD. So if you have calculated your determinant for your x, you don't even have to recalculate it over here. It'll be the same thing. I'm going to put it down just so we can see that those two are the same, these two pieces right here. But I could just write 11 on the bottom because I know it's going to be there. All right, let's find the determinants there. 1 times 29 minus 17 times 3. That's going to be 51 over, again, I already calculated it over here. I'm not going to do it again. It's 11. And then when I simplify down, get 29 minus that 51. I get negative 22 over 11, or negative 2. So I now found that y is negative 2. But what do we do every time when we have an x and a y? That's right, we put it into a coordinate. So 9, negative 2 is our final answer. All right, let's jump over and see some more examples. This next example, we could do substitution elimination, but when we have matrices and Cramer's rule, we can find this gets a lot faster. So let's do that. If you aren't fast with this yet, and you don't just have those formulas memorized, it's nice to have a copy of the formula right next to you. Again, just because we're only on our second example, I'm going to write out what each of these are. You don't have to do this, it just helps some people visualize. Notice I didn't have to adjust my equations at all because they were already in standard form. So let's set the first one up. X equals, I always know my E and my F come first. Solutions come first in the matrix. And then this is one of those patterns that maybe not everyone will find useful, but I find it useful. If we're trying to find x, we want to eliminate our y's. So I use the y coefficients, the 5 and the 3. Again, if you see the formula and the formula works for you, don't mind my shortcuts. I just know that if I want x, I got to get rid of the y's, so I have to eliminate those two by using them. A, B, C, and D, again, you can see the pattern that I see. As long as they're in standard form like this, I know that my bottom determinant is going to be the numbers in this box, just without their letters. So it's going to be 3, 4, 5, 3. And that's how I do it the faster way, so I don't have to keep memorizing the formula for the bottom box. All right, when I do this, I get 57 minus 35 over 9 minus 20. That becomes 22 over negative 11, or negative 2. This is just determinants again. Top down minus bottom up, top down minus bottom up. For y, the only difference in the top matrix is that now your solutions come second. Instead of putting them in that first column, we put them in the second column. And now, because I want to get rid of my x's so I can have y values, I need to use the coefficients that are in front of my x's. Again, the box on the bottom will be the same, so I don't even really have to repeat it over here. I just know that it's negative 11 from this side, so I'm just going to put it over negative 11 and save myself some time. But let's do the determinant there. Top down ends up being it ends up being 21 minus 76 over negative 11. Simplify that down to negative 55 over negative 11, or just 5. So this is my y value. This is my x value. I put it as a coordinate point. It becomes negative 2, positive 5. All right. I'm not going to narrate this one. I'm just going to go through it so you can see how it's set up. This one ends up having some ugly numbers in it too, so just be aware that that does sometimes happen and it's totally okay. All right. So my x setup. Yes, I'm doing it a little different. Up here I did x and y next to each other. Now I'm doing x above y, but that's just because I'm not showing you this step where I calculated my determinant. And your final answer for this one is that. Again, I'm going to see those ugly fractions and be like, stop. No. You're good to go. Don't worry about that. All right, this last one is just a little bit different, and the only reason why is because it's not in that standard form, and we can't work with anything that's not in standard form. So, in order to put this in standard form, I got to get rid of those fractions. My least common multiple here of 2 and 4 is that 4, so I multiply this entire thing by 4. This equation ends up giving me 2x minus 4y equals 1. This one, the least common multiple here between these two is 5. When I multiply that, I get negative x plus 2y equals 5. Except I don't want a negative in front of my x. I don't want that coefficient to be negative, so I'm just going to multiply this whole thing by a negative 1, and that just flips all of my signs. So I now have x minus 2y negative 5. So this equation then went down here. So the final equations that I'm going to be using are this one and this one. All right, let's set those up. As you saw for the last one, I'm not going to set up my letters anymore because as you get faster, you'll just, again, start to recognize the patterns. Where do the big numbers go? Where do the coefficients go? Not going to set them up here either, but if you feel more comfortable writing out your coefficients and putting them in, more power to you. All right, x equals on this last one, I get to this point and I have my two answers. My x is equal to this, my y is equal to this. Except this is an issue. When I calculated my determinant for my lower box here, I got negative 22 over 0 and negative 11 over 0. But this is not possible. We cannot divide by 0. So what this essentially means is that there is no solution here. It is not possible. When we were doing systems of equations and we solved two equations that were maybe parallel, you would end up getting something at the end that was like 0 equals -3. And we knew that if we got a false statement, we didn't have any solutions. It broke math, essentially. So that's what happened here, is we ended up dividing by 0, and we don't get an answer. All right, I hope this video was helpful. Please let me know if you have any questions.